Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we're going to begin our project of stock market analysis and visualization. First off, we have to fetch our stock data. So here I am in Google Colab at colab.research.google.com, my free online code editor, and I'm going to be coding in Python, and I'm going to fetch my data. All right, so to fetch our data, first let's make a list of all of these stocks that we want to fetch. So I'm going to make here stocks list, and I'm going to create here a list or an array, and I'm going to create a list of strings, and each of these strings is going to correspond to one of the tickers for the stock that I want. For example, Facebook is FB, and Amazon is AMZN, Netflix is NFLX, and Google is GOOG. All right, so these are the four stocks I am going to be using for this project. Of course, you can use any stocks that you'd like. These also happen to be the FANG stocks. All right, so we have a list of all of the tickers for these stocks. Next up, we have to loop through all of these stocks. So let's make a loop. For every stock in the stocks list, we are going to grab that stock. So we're going to call globals at the current stock and assign it to equal a new data reader. All right, so in order to use data reader, we do have to import it from pandas. So let's include that at the top of our code cell here. I'm going to import from pandas underscore data reader. I'm going to import the data reader class. And we do have to import pandas as well, because before we can import from pandas data reader, we need the whole pandas library. Pandas is very commonly used as a library to help with data science and machine learning. All right, so now we can instantiate this data reader class. For this data reader, this is going to allow us to put in a ticker and a website, and then we will get stock information from the specific website. Globals is going to take the stock tickers and create it into a global variable. So if we call the ticker, it'll display a data frame. So first, let's fill in this data reader constructor. First, we have to pass in the stock that we want to get. Then we're going to pass in the website that has the stock data. In our case, we're going to use Yahoo Finance. All right, and after that, we also are going to pass in what we want to get. And well, what we want to get is going to be the actual stock itself. And we have to tell it the end and the start times. So let's make here start date and also end date. Okay, you can just call them start and end. So start and end, these represent the date range that we want for the stock. Do we want 5 years, 10 years, 6 months, etc.? So let's define those variables. We're going to define start and end. Let's start with start. Okay, we're going to use date time in order to define a date for the starting date. So in order to be able to use date time, we do have to import it. So at the top of your cell, make sure that from date time, you import the date time module. All right, and because we're using Google Colab, we don't have to install pandas or datetime. It's already pre-installed, but we do just have to import them. If you're using a different code editor, then take note that you will have to install pandas and possibly datetime. All right, so let's define the starting date. All right, so we can do a year ago. To do that, we'll take our current day, which is datetime.now, and we are going to then subtract 1 from its year. So we can get the year property from any date just like that and subtract 1 to give us 1 year ago. Then we can get the current day's month as well. And finally, we can get the current day's day. So just like that, we'll get the same day and the same month, but 1 year earlier. So we're going to have 1 year of stock data to work with. Now let's also define our ending date. So we'll make a variable called end, and for that we'll just use datetime.now, which is just today. So that means we'll go from a year ago until today. We will get the stock data. All right, so once I run this cell, because I'm calling globals here, this means that it's going to take all of the stock tickers, FB, Amazon, Netflix, and Google, and it's going to allow me to call the ticker as a global variable. So let me show you. I'll run this code cell, and then I'm going to make another code cell after that, and we can get the results for our stocks. Okay, great. So the cell ran successfully. Now I can call any of these stocks. For example, I can call FB, and I can use the describe function to get its contents. And look at this. We get this data frame returned where we have some statistics about the stock. And each column represents every column from that stock: the high price, the low price, the opening price, the closing price, the volume, and closing. All right. And we can get the description for every single stock. Because we used globals here to create a global variable for every single stock, that's why we can just reference the stock by its name. For example, let's try Amazon next. Let's just print out Amazon this time and run that code cell. Okay, so this time we didn't call describe, so we don't get this nice data frame. We just get all the contents. So we can see that we have the date, we have the high, the low, more columns, volume, and close. So we have 252 rows of data, and as well, we have 6 columns. So we have 252 rows because that's every day that the stock market was open. It's not open on the weekends. And we have 6 columns because those represent all of the features we have. We have here high, low, open, close, volume, and close. So those are 6 features, which is why we have 6 columns. And of course, we have the date, which refers to the date of all of the prices. And we have a whole year's worth of stock data on all 4 of our stocks. Awesome. Okay. We can also get information from the stocks. For example, let's do Netflix next. I'll make another code cell. This time I'm going to call info instead of describe. And we can see here with the info function, we get more information about the actual data frame. So we can see it's a class of pandas.core.frame.dataframe. So we've created what's known as a pandas data frame. These are very commonly created. They take data in the form of a CSV file or similar, and they turn it into a data frame which is more suitable for data science. And that's what the data frame looks like here. You can see with the describe function, we get some statistics about the data frame. All right, and that is the info function. So we can see we have here the pandas data frame, and that is because we use that pandas data reader. And when we call this data reader constructor, we create a data frame for each stock. And that's what we have returned here. So we can see that we have the number of entries and the range of the dates. We also have the column count. We get the number index of the column. We get the column name. The non-null count means the number of rows that are not null at that column. And we have the data type. So every data type is a float, meaning it can have decimal places, except for volume. It's an int because volume is just the count. So it's not in halves or quarters, so we don't need decimal places. We also get the memory usage as well. So we are using 13.8 kilobytes of memory for this data frame. Awesome, and that is how we can fetch stock data into our project. Next up, we are going to learn how we can visualize some of this data. So we're going to visualize our features of our stocks. Join me in the next lecture where we will continue our project. Hello everyone and welcome back to our course. In the previous lecture, we learned how to fetch stock data and load it into our Python project. In this lecture, we're going to learn how we can visualize features of that stock data. All right, so let's start with a stock. We can use, for example, Google, which we haven't used before, also known as alphabet stock. All right, so let's create a new code cell, and we can reference that stock just by its name because we made it a global variable. Then we can get one of its columns by accessing its column by its name. So we have here, like you would get a value from an array or a list at its index, we can do the same, but we just have to pass in the name of the column, which is @close. Let's start with that. So we are using one of the columns, and we're just getting it from that data frame. So this is how we can grab a column from the data frame. Then we can use the plot function to create a plot out of that data frame. This will allow us to visualize our data. Right, I'm going to run that code cell, and look at this. Here we're using the matplotlib library to create this plot out of the data. So we have here on the y-axis the @close. Then on the x-axis we have date, and we can do this for any of the columns we want. For example, we could do it with the high column, which represents the high value of the stock on that day. And here we go, we have another graph generated. We have on the y the high price, and on the x-axis we have the date, starting with the first day in our data set, which was 1 year ago from today. So we have here a whole year's worth of data. You can see the trend of the alphabet stock climbed quite high. All right, and we can get any kinds of plots we want. So for example, you could take Goog at a different column, for example, volume, and we can call plot again. And if I run this code cell, I am going to see this time the volume. All right. The volume is on the y-axis, and the date again is on the x-axis. So the date is by default always the x-axis when you grab a column. You can also specify if you want a legend. So if I set legend to equal true here and rerun my code cell, then I get a little legend here at the bottom that says what the line actually represents. And legends are very useful to have. Typically, you always want a legend because often you'll have more than one line on your chart. As well, you can specify the size with the argument fig size. For example, I can change this figure size to, let's do 14 by 6. Right, then I'll rerun this code cell. And okay, now we get a lot larger of a plot here. A lot clearer as well. Okay, next we can create a moving average graph using the column names. So let's do that. I am going to first make a loop. So let's loop through every moving average in our moving average intervals. So what kind of moving average intervals might we want? Well, we can do any range that we want, like 100-day moving average, 20-day moving average. Let's define a list of moving averages. So I'm going to here moving average intervals, and I'm going to create a list of integers. Let's do, for example, you can do 20, 50, and you can do as well 5. So let's do 5, 20, 50. Inside of this loop, we're going to define a variable column name, and we're going to assign it to equal moving average for %s days. All right, and then we're going to fill in that percentage with a string of our moving average. All right, and after that, we can grab one of our stocks like alphabet, and at the column name, we're going to create a new entry. So you can actually put in new entries like this. We're going to assign it to equal goog at one of the columns like @close dot rolling of the moving average, and then dot mean. This is the formula for getting a moving average. This rolling function is going to create a moving average using this specific column that we selected with the help of the mean function as well. All right, now we are going to have 3 new columns that we just created. Moving average for 5 days, moving average for 20 days, and moving average for 50 days. So let's now make a plot for every single one of those new columns. Make sure you're outside of the for loop. And we're going to grab our alphabet stock, and we're going to then grab it at several columns. That's why we're using double square brackets here. We'll do add close followed by moving average for 5 days. And note that that's exactly the same as the name I put here, just filled in with one of the days. Then let's do our next new column, which is a string of moving average for 20 days. All right, and then we had one more, which was moving average for 50 days. All right, great. So then we just have to call the plot function on that, and we're going to create a new plot for all of our columns here. All right, so let me then run this code cell and we'll see our results. Okay, look at this. So now we have this chart with 4 different lines. Okay, and I'm going to zoom in here so you can see. On the Y, we have the value of add close at that day. And then on the X, we have the date. And we have 4 differently colored lines. Add close, moving average for 5 days, moving average for 20 days, and moving average for 50 days. Right? I can make this a bit larger just by passing in here the fig size argument. So I'm going to pass in here a figure size of, let's do 14 by 6 again. Then I just have to rerun the code cell. And okay, it's a bit larger now of a graph, so it's easier to read. So we can see here the orange line begins 5 days after the start because it's a moving average for 5 days. The green line begins 20 days after the start because it's using a moving average of 20 days. And the red line begins 50 days after the start because it's using a moving average of 50 days. Awesome, and that is how we can visualize moving average. Next up, we're going to learn how we can calculate daily returns on our stocks. So join me in the next lecture where we will continue our project. Hello everyone and welcome back to our course. In the previous lecture, we learned how we can visualize features of our stock data. We also learned how we can visualize different moving averages. Next up, we are going to learn how we can calculate daily return. So I'm going to make a new code cell here in our project. I'm going to select one of our stocks. We can be consistent and stick with alphabet stock. And let's make a new column that we will call our daily return. All right, and to calculate daily return, I'm going to grab the alphabet stock at the column of add close. And I am going to use the function %change, which is going to give me the % change per day for the adjusted closing price, okay? So I'm going to take that column, adjusted closing price, and I'm going to calculate the % change per day. That is daily return, all right? And after that, I can then access that newly created column called daily return in the Goog stock, and I'm going to use the plot function to create a new plot, all right? Then I will run this code cell, and here we have a plot of daily return. Now I'm going to just make this a bit larger, first of all, and then we're going to change the line style. So let's make this 14 by 6, rerun that code cell. Okay, there we go, a lot easier to read now. Other than changing the figure size, I'm also going to add a legend here because typically it's best practice to always have a legend. So we have this blue line that says daily return. All right, and what we have plotted here is our daily return versus the date. And we're starting at the first day of our historical data, which was 1 year prior to the present day. So we're going all the way from 1 year ago to the present day. All right, and as well, we can change the line style. So let me just create here line style. We can make it a double dash. That's another argument here. All right, a bit easier to see the separation. And as well, we can add a marker argument. So I'm going to set a marker of lowercase o here. And look at that. Now we have a marker at all of the maximums and minimums. So the local maxima and minima of each day. So we can see here for each day what is the value. Right, now it may be a little hard for you to read with the marker, so you could just remove that if you don't want to see it. Here you can see that the daily return does vary from about negative 0.1 to positive 0.1. I'm just going to put the marker back in and make my chart a little larger, that will make it easier to read. Here you go. I'm going to zoom out as well so you can see this. All right, there we go. So that is our plot of daily return. We can also compare the returns of different stocks. For example, what if we wanted to analyze the return of all of these stocks that we have in our list? Well, we can do that as well. So that's a new topic, so let's work on that coming up in the next lecture. We will learn how to compare daily returns of stocks. Hello everyone, and welcome back to our course. In the previous lecture, we learned how we can visualize and calculate the daily return of a stock. Next up, we're going to learn how to compare daily returns of multiple stocks. So let's create a new code cell and we will get started. First, let's make a data frame using our data reader to read stocks from the web, which we have done before, but this time we're going to only get the closing columns, specifically the adjusted closing price column. All right, so I'm going to zoom in here and I am going to grab my data reader and pass in my stocks list. I'm getting my data from Yahoo Finance at the starting time or date and the ending date. The result of this is going to be the data frame I already have. But if you pass in here that you only want one of the columns like add close, then you can get just that adjusted closing price. Now the other option is just to see here, grab your globals at the current stock and get it that way, but this time we're making it not a global variable. We can just grab this result here as our adjusted closing data frame, because the data reader returns a data frame, a Pandas data frame, and we're only getting the adjusted closing price column, and that is just going to be one data frame. All right, we can also now verify that we created the data frame successfully by calling the data frame. You can print out the data frame itself, run this code cell, and you will see your results here. You have at the top, the symbols are for stocks. You have the date, and then you have values for each of the dates, and that value is the adjusted closing price. Now you can also just get the head, so you can take that adjusted closing data frame and just call its head function. If you run that, then you're going to see here just the first 5 entries, okay, just to verify that we have it. All right, now let's get the daily return for this column. And that's going to give us the daily return for all 4 stocks instead of just 1. So how do I get the daily return? Well, I'm going to take my data frame, which is adjusted closing data frame, and I'm going to use the same function we used in the previous lecture where we coded out that percentage change function. That's going to give us the daily return. We can store this as our stocks returns variable. All right, then we can verify that we did that correctly by grabbing stocks returns. We can print out its value. And look at that. Here we go. We can see here for the first day we have not a number, nan, because we can't have a daily return for the first day. But starting with the second day in our historical data, we have here percentage change, which is as a decimal, not a percentage. If you wanted it as a decimal, just multiply it by 100. Some are negative if you have a negative return, some are positive if you have a positive return. Awesome. Okay, now, next we're going to learn how we can compare 2 stocks' daily returns. So for that, we're going to visualize the daily returns, and we're going to be using the help of another library known as Seaborn. So let's import the Seaborn library. This is a very commonly used library. All right, and because we're in Google Colab, we don't have to install it. It's pre-installed, but we do have to import it. All right, and now let's use Seaborn, which has many functions to create plotting, visualizations, and graphs. We're going to use the function joint plot. And let's first compare one stock against itself. Let's do Goog versus Goog. All right, here I'm passing in the X and the Y, so I'm just comparing the same stock against itself. I'm also going to pass in a data argument, which is going to be my stocks returns, which I just created here, stocks returns. I have to pass in that data frame for this joint plot. And Then I can also pass in here a color such as blue or orange, better yet. All right, and really the color doesn't matter much. Okay, and now what do you think we'll get before I run this code cell? If you compare one stock with itself, what kind of line or chart or graph do you think we'll get? What kind of slope would be of the line? Well, it's like comparing the same numbers against themselves. So you should have a linear relationship, 1-to-1. So let me run this code cell and look at that. We get this joint plot, and yes, we get this linear line. The reason we get this linear slope, perfectly linear, is because we're comparing goog versus goog. That means that if I have 0, I'm going to have 0 on the y and the x. Because if you're comparing something against itself, the comparison or the ratio is always 1-to-1. And that's just because this is going to be very easy for you to understand. So you can see here we have all the data points in orange, and we can also see that we have more data points clustered in the center because that's the distribution. And we also have these bars at the top and the right. You may be wondering, what is that? Well, this is a histogram that's been created showing you the frequency of the data points. So you can see that as the number of data points increases, the bar at that exact x and at that exact y also increases in size. That's because a histogram shows you the frequency of data points. So you can see we have very few data points at negative 0.1 and also very few data points at 0.1. That's because most of the returns were around 0. Okay, and that is just comparing goog versus goog. Let's get into some fun stuff and compare two of our stocks against each other. So I'm going to create another code cell, and I'm going to use Seaborn again to make another joint plot. This time, let's compare Amazon versus Netflix. How about that? AMZN versus NFLX. Right, so I'm going to paste that in there, compared against NFLX. I'm going to pass in my data. It's still the same data, my stocks returns. I'm just getting specifically these two columns for the X and the Y. And the color also optional. Then let's run this code cell. And look at this. We get the default color blue, and this time we are getting a relationship that's not linear. It's a lot more spread out. What is the reason for that? Well, we're comparing Netflix versus Amazon. And we can see here we have the returns for Netflix versus the returns for Amazon. And because it's not 1-to-1, that's why the data points are more spread out. We can also see the most frequent data points via the histogram at the top and the right. There are so many possibilities of relationships between stocks and comparisons, rather. So we can repeat this comparison analysis for any combination of stocks inside of our inside of all of our columns. We can compare every single stock versus itself. And we can just use pair plot if we want to see all of our stocks compared at once. So for that, I'm going to call Seaborn .pair plot, and I'm going to pass in here my data is going to be my stocks returns. Then I'll run this code cell here, and we're going to this time generate a huge pair grid where we compare all of our stocks against each other as a pair though. So we have Goog versus Facebook, Goog versus Amazon, Goog versus Netflix, Goog versus Goog. And we can see here, we get that comparison. Now, you may be wondering, why is there scatter charts, but for histograms or bar charts? That's because if you are comparing Facebook versus Facebook, you're comparing itself versus itself. So the pair plot actually doesn't even generate for you that linear slope just because it's obvious. Instead, it will give you a histogram. And it will do that at these Amazon versus Amazon, Netflix versus Netflix, and Google versus Google. But for all the other ones where you're comparing two different stocks, then you will get a scatter plot. Awesome. Okay, and we can also drop any null values with drop NA. That's a useful function to add when you're creating this pair plot, because that's going to drop any null values or not a number. All right, there we go. Very similar because we didn't have many not a nulls. This is a really fast way to compare all of our stocks because all we have to do was call one function. So you can either compare functions one by one, or just get a pair plot function to show you all of the possible different correlations between all of your columns in your stocks returns in your data frame. Now, do be careful, because let's say you had 100 different stocks. Well, then you're creating 100 by 100 matrix, and that can actually be too large, so you'll just possibly end up with an infinite loop or an exception that says that the size of the pair plot is too large, because 100 by 100, that's quite a lot. So just be careful when you are comparing your pair plot, when you're making the pair plot, if you have a lot of columns. You may have to split the pair plot into subplots in that case, because if you have a lot of columns, you won't be able to fit it here into Google Colab. And that is how we can compare daily returns of different stocks. Coming up next, we're going to continue our comparison, and we're going to learn how we can compare a different feature. Let's compare this time closing prices, and we're going to learn how to make a different type of graph while we're at it, known as a heat map. Very exciting stuff. So join me in the next lecture where we will continue our project. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to compare returns of our different stocks. And next up, we're going to learn how we can compare a different feature known as closing prices. Any other feature would do as well, actually. And we're going to learn how to create a heat map as well as a pair grid. All right, so let's create a new code cell and we will jump right in. Let's use Seaborn again to create a pair grid starting off. And the data we're passing in is going to be the same data frame we used in the previous lecture where we coded it out. Let's see. And that is going to be, yes, our stocks returns. And that is going to be here where we declare that stocks returns. It's our adjusted closing data frame. Okay, so we want to actually grab the data frame and pass it in as an argument for this pair grid. All right, and the result is going to be a figure of our returns. So we can create here a returns figure. Then we're going to take this pair grid and we're going to put it into a plot. So for that, we're going to use the help of another library known as matplotlib. Let's import matplotlib.pyplot as pyplot. So pyplot is a sub-library of matplotlib specifically for Python plotting. PyPlot is similar to Seaborn, but they do create different types of grids. So what I'm going to do is take the returns figure, my pair grid, and I'm going to use the function mapUpper. This is going to allow me to specify the types of plots that I want for the upper triangle. So here, if we look at this previous graph that we made, we can see that we have an upper right hand corner full of scatter plots. We have a diagonal full of histograms, and we have a lower right-hand corner, or lower left-hand corner, I should say, of scatter plots. And so we can actually specify what type we want the graphs to be. Let's start by specifying what type we want the upper right graphs to be. For that, we're going to use pyplot. We are going to use pyplot's scatter plot here. So that means the upper right-hand corner will have scatter plots. Then let's next map the diagonals with the function mapDiag. We're going to use pyplot.hist to create a histogram. We're also going to specify the number of bins to 30. That's the number of columns. And finally, let's map the lower right-hand corner. We'll grab our returns figure and we'll use the function mapLower. We're going to actually use a Seaborn type of plot known as the Kde Plot. Now I'm going to run this code cell, and we're going to see our pair grid with specifically the types of plots that we wanted to show. So give it a minute to execute, and there we go. Look at this. Now we have here our new pair grid. At the top right-hand corner, we have a scatter plot. Here we're comparing every stock versus all of the other ones. So that's why we have here 16 different graphs. And you can see here, some of them are just the reverse of each other. For example, Facebook versus Amazon, and then there's Amazon versus Facebook. So at the top right, we have a scatter plot comparing the daily returns of different stocks. In the diagonal, we have a histogram, just because the diagonal is the stock versus itself. And then in the lower right-hand corner, we have a KDE plot. A KDE plot is also known as kernel density estimate. And it's visualizing the distribution of observations in our data set. It's very similar to a histogram. Here, we're seeing the data using a continuous probability density curve. So this KDE plot is similar to a histogram, but it's less cluttered. And it's very useful, especially if you have multiple distributions. And like a histogram, the quality will depend on our selection of smoothing parameters. So here we can see the distribution, and the more densely colored the lines, the heavier the distribution. So this allows us to see, similar to a histogram, but for the scatter plot, the density. So as you can see here, Amazon versus Facebook, and we have Facebook versus Amazon, right? So the two are different plots. One is a KDE, one is a scatter plot. With the KDE, we can actually see density more clearly, whereas with the scatter plot, we can still see density but less clearly. And as well, the scatter plot is showing us the density of actual data points, whereas for our KDE plot, we are seeing a continuous probability density. All right, next up, now that we have created our plot, let's actually calculate correlation. So I'm going to make another code cell here, and I specifically want the returns from all of them. So that is going to be in here, stocks returns. So I'm going to grab this stocks returns, and I'm going to get the correlation. So let's come back down to our code cell, and let's pop in those stocks returns. And we can actually use a function called core to get the correlations. So I can print out the results of this and run that code cell. And look at this. Now we have similar to our graph, but in numerical format. So we see the correlation of the returns for different stocks. Facebook versus Facebook, the correlation is obviously 1 because it's 1-to-1. Then we have Facebook versus Amazon, Facebook versus Netflix, Facebook versus Google, and we can see the correlation. All right, let's save this value, stocks returns dot core, and let's make what's known as a heat map out of that. So I'm going to create here a variable correlations and use the function core. Then I'm going to use Seaborn's heat map function to create a heat map. For the heat map, I have to pass in the data, which is my correlations. And I can also pass in FMT. We'll do 6G. You can set other values as well, optionally, like annotations, colors, and the shape of these squares. So now when I run this code cell, look at that. I get a heat map. On the y-axis, we have symbols, and on the x-axis, we also have symbols because we're comparing all of these stocks versus one another. On the right-hand side, we have this color scale going from 0 to actually 0.55, going from 0.55 at the bottom to 1.0 at the top. And those values are correlation. So if you have a beige color, that represents a 1-to-1 correlation. That's why we have a beige color on the diagonal. If you have an orange color, you have 0.9 correlation. We actually don't have orange anywhere. If you have 0.8, you have a red color, which means you have a high correlation. We can see Google versus Facebook, Alphabet stock versus Facebook stock. That is a red color, which means they have a high correlation. Then slightly less than that is purple, 0.7 correlation. We have a lot of purple. And the least correlation is 0.55, and that will be a black color. So still some correlation, but not as high as Alphabet stock versus Facebook stock. So as you can see, a heat map is a really great way of getting a fast visual. The reason being that we can quickly see with color how different features like stocks correlate to each other. Next up, we're going to learn how we can analyze risk with our stock data. So join me in our next section. We are going to learn how we can calculate risk in multiple ways. Hello everyone and welcome back to our course. In the previous section, we learned how we can analyze features of our stock data. And in this section, we're going to learn how we can calculate risk. Starting off, we're going to learn how we can visualize standard deviation with a graph. So let's jump into our same project, continuing on, and we're going to make a new code cell. Here, I am going to first get all of my returns, and those are inside of stocks returns. And I'm just going to make sure to drop any null values with the function drop NA. Then I can save that as a new variable called my returns. Then I'm going to use pyplot to create a new scatter function. Let's pass in an x-axis. The x is going to be our returns.mean, so the average of our returns. The y is going to be our returns.standard. And in this way, we're plotting the standard versus the mean. We're also going to pass in a value that can define the area for the circles in the plot. And that is an argument known as s. So let's create here circles area. And let's create that variable, circles area. We can just use numpy dot pi times a value like 15. Numpy is another library that we have to import, so we can just import the Numpy library. The Numpy library has a lot of useful tools for scientific computing and data science. For example, it has the Numpy type, which means that it acts as a regular Python list, but has a lot more capabilities, a lot more functions, and also the Numpy list type or Numpy array type. It is much faster in terms of processing. That means it's perfect for data science and machine learning, which can often use a lot of data. All right, so here I've defined a scatter plot. And next, let's set labels. So we can set the x label for the x-axis. This will be expected returns. Then let's use pyplot.y label to label the y-axis. The y-axis is risk. All right, and I can already run this code cell and see some action. Look at this. We have risk versus expected returns. And I want to make a loop to go through all of my data. So for every label, x and y, in a zip of my returns.columns, my returns.mean, and my returns.standard. Right? So I'm looping through the label, which is the columns, the x, which is the mean, and the y, which is the standard. And I'm going to call pyplot.annotate to create a new annotation at every single coordinate. I'm going to pass in the label, which is the text. The xy argument is an xy pair. The xy text argument is going to be 50-50 for the size. Then we're going to pass in text coords. I'm going to use offset points, as well as HA is going to be right and VA is going to be bottom. Then we can also pass in arrow props. This is going to be a dictionary where we can set the arrow style. I'm going to use just a dash, and we can set connection style to equal an arc3 with a radius of -0.3, very commonly used. And that just sets the type of arrow. So now if I rerun this code cell, okay, look at this. Now we just have here an arc pointing to the data point and then an annotation explaining the data point. So we have risk versus expected returns. We have 4 blue dots because we have 4 different stocks in our data set. And here we can see we can compare. We have first each stock's expected returns on the x-axis. Facebook had the smallest expected returns and Amazon had the highest expected returns, but even still all the returns are quite close to each other because our graph only goes from about 0.001 to 0.0025. All right, and let's see. On the y, we have our risk going from 0.024 and all the way to 0.031, so still not a huge range. And we can see that lowest risk was the Amazon stock, and it also had the highest returns. The highest risk was the Netflix stock, but it did have the second highest returns. So look at that. We can get quite insightful data by building out this visualization, or we can visualize the standard deviation. Standard deviation, also known as risk, and expected returns is the average of all of the returns for that stock. All right, next up, we are going to learn how we can calculate value at risk and also visualize it. So join me in the next lecture where we will work on that. Hello everyone, and welcome back to our course. In the previous lecture, we learned how we can visualize risk or standard deviation versus expected returns for each stock. In this lecture, we're going to learn how we can calculate value at risk and also visualize it. So I'm going to make a new code cell, and I'm going to use Seaborn to create another type of plot known as a Dist Plot. Then I'm going to choose one of my stocks. For example, I can do Goog, and at its column of daily return, which we created, we're going to first drop all the possible null values. Then we're going to assign the number of bins we want to be 100. All right, and then I'm going to run this code cell, and I'm going to get this plot. Look at this. So we have a histogram, but we also have a line that shows us the distribution of the histogram. So on the Y column, we have density, and on the X column, we have daily return. And we can see here that the highest frequency of daily return was about 37, and the value was about 0. So that was the most frequent daily return, but then we can see all the other ones as well. Okay, and next, let's now get one of the quantiles from our returns. So we have this variable that we created earlier called returns. First, let's just get some quick info from it. We can just call returns.head to return the first 5 columns of that data frame. Here we go. So here we can see the returns for the first 5 days in our data set. Next, let's get a quantile. So we're going to get an empirical quantile of daily returns. Let's start with a value like 0.05, for example. So we'll take returns, and at one of the columns, like FB, we can get a quantile of 0.05. Then when I run this code cell, let's get our result. Okay, we have negative 0.04. So that means that the 0.05 empirical quantile of daily returns is negative 0.04 for Facebook. So 95% of the time, the worst we can lose per day is going to be 4% of our investment. So this is the value at risk as a decimal, but if you multiply it by 100, let's just multiply that value by 100 here and hit run. Then we get this value 4, and that represents the percentage. So this means that the worst we can lose per day is 4% of our investment for the past year. We can choose any quantile value we want. For example, we could choose 0.95, hit run, and rerun this code cell, and we get this time the value 5. So that represents the 0.95 empirical quantile of daily returns. So this means that with 5% confidence, 5% of the time, the worst that we can lose per day is going to be 5% of our investment for the past year. All right, and that is how we can calculate value at risk. Next up, we're going to learn another form of analysis to calculate risk, known as Monte Carlo analysis. We're going to calculate risk and also visualize it. So join me in the next lecture where we will continue our project. Hello everyone, and welcome back to our course. In this lecture, we're going to learn another type of analysis to estimate risk, known as Monte Carlo analysis. So for that, we're actually going to define a new function to keep the functionality contained. And we're going to call this, Monte Carlo analysis. We're going to pass in here a starting price, our days of the year that we want to calculate the risk for, as well as our average, MU, associated with the drift, and sigma, which is the volatility of the stock. Then let's open up that function. All right, first we're going to calculate price, and for that we're going to use a NumPy array of zeros, which means we're just going to have an array full of zeros, and we pass into the argument of this function the size of the array. The size is going to be days, so it's going to equal the number of days that we pass into the function. Then price at the 0th index should be the starting price. So we're setting here the initial price. Next, let's define a shock variable. We're going to use numpy.zeros again on the number of days, as well as a drift variable. We're going to use numpy.zeros of days. Next, we're going to loop for every day in a range starting from 1 up to our number of days, because we already set the 0th index. We're going to take shock at that day and use numpy.random.normal to create a new random number. We're going to pass in a lock value, which will equal our MU argument multiplied by DT. DT, that is going to be 1 divided by our days. So let me just define here. I'm going to define days and DT outside of the function. Days is 365 and DT is 1 divided by days. As well, for the random.normal function, we're going to pass in a scale argument, and for that we're going to use a value known as sigma, which is the volatility of the stock, the argument that we're passing in, multiplied by numpy.square root of our dt. So let's define sigma. Sigma, we're going to take our returns and use the standard of it, as well at the specific stock we want. Let's use how about Netflix stock. All right, and MU here, let's define that as well. MU is going to equal our returns dot mean, so the average, again, at that same stock. We can use Netflix stock. All right, and after that, we have defined shock. So let's define drift at that current day, so for every day. Drift is equal to our MU, so our average, multiplied by the DT. And as well, we want to define the price array at that day. The price is going to equal the price at the day minus 1, so the previous day's price, plus the price at day minus 1 again, multiplied by the drift at that day, plus the shock at that day. So that's the formula for calculating the stock price. You take the previous day's price and you add the previous day's price multiplied by the drift plus the shock. Then after that, make sure you exit the for loop with a backwards. So make sure the indentation is outside of the for loop and return the price. So we're going to have the price returned, and that will be an array. So now how do we call this function? All right, well, we're going to loop through all of the indices in our price array. So for every run we want in any range, like 100 runs, we're going to use pyplot and use the plot function to plot our array. What is our array? Well, our array is actually what Monte Carlo analysis returns. So I'm going to call Monte Carlo analysis. I'm going to pass in my starting price, my days, my MU, and my sigma. The result of this is going to be my price, which I can just have as a variable, and then I can plot the price. Now, we do have to define the starting price though. So let's figure out starting price. We're working with Netflix here, so I'm just going to create a new code cell, and here I will define my starting price. All right, and my starting price is going to be the first value inside of my Netflix array. So I can just grab Netflix and call head to get the first 5 rows from that stocks data set, that data frame, And we can see that the first value is 372.82. And that is going to give for me the high on the first date. I can use high, low, open, close volume, or adjusted closing price. I am going to choose adjusted closing price here. That's the value we want to use because it's the value that we had that affects our returns. So you want to find the column that you used for returns. All right, and so I'm going to copy that 368.7 and I'm going to assign that to equal my starting price. So I'm going to create a variable starting price and assign it to equal 368.7. Just make sure you do run that code cell if you want the variable to be actually created. So that will allow me to use starting price later on here. So then I'm going to call pyplot.plot, and that will take every item in the price array and plot it. I'm also going to add here pyplot.xlabel because typically it's good to add labels, titles, legends where possible. And so our x label is days, and then we'll call pyplot.ylabel. Ylabel is price. Then I'm going to run this code cell and I'm going to see my plot results. And look at this, we have quite an intense plot. It's because we have one line for every Monte Carlo analysis. Okay, so we have price on the y-axis going from about 330 to 400. We have days on the x-axis going from about 0 to 365, which is what we specified. And we can see here we have a line for every day using Monte Carlo analysis. And this is how we can use Monte Carlo analysis to estimate risk. And at the end, we can see here we have all of our lines ending. So we're performing Monte Carlo analysis for a range of 100, but let's say I reduce this to a range of 10. Rerun the code cell. Look at this. Now I only get 10 lines of Monte Carlo analysis. It might be easiest with just 3 to understand from a very beginner perspective. So here we have 3 lines, right? And you can see they start at the same point, but why do they end at a different point? Well, the orange line ends at a price of 375. The green line ends at a price of 370, and the blue line ends at a price of 350. So they're not that far off, but they still differ. The reason being that when you call Monte Carlo analysis, you're calling that function. And here you're calculating price using shock and drift and a starting price. The starting price is the same because we hard set it, but then we use numpy.random. And because we're using numpy.random for every single day, that generates a brand new random number for every single day as our shock value. So because we have that random shock value every single day, that's why our 3 lines end up looking different, because we have that random shock value. And that is how we can perform Monte Carlo analysis. Coming up, we're going to finish up and we're going to learn how we can visualize price distribution. Join me in the next lecture where we will finish our project. Hello everyone and welcome back to our course. In the previous lecture, we learned how to analyze risk with Monte Carlo analysis. And in this lecture, we're going to finish up our project by learning how to visualize price distribution. Visualizing the price distribution is going to allow us to make better sense of our Monte Carlo analysis, because currently there is some variability in our predictions, and we're going to make sense of that variability with a histogram. First, I am going to make a new variable called simulations, and I'm going to make a numpy.zeros function. So I'm creating a numpy array of zeros. The size is going to be my number of runs, and this time my number of runs, I'm going to increase it to 1,000 instead of 3 or 100 as we saw previously. Then I'm going to loop for every run in a range of 0 up to my number of runs. I am going to take my simulations, this should be plural, and at the current run, I'm going to assign it to equal Monte Carlo analysis. So this means I'm going to store the results of my Monte Carlo analysis in this array simulations. For Monte Carlo analysis, I do have to pass in the starting price as well as the days, the MU, and the sigma. And then I'm going to store the results of that analysis at the days minus 1. Right, so days we had earlier, we declared this to 365, and we declared all the other arguments as well, so we're good to go. All right, and that's just going to perform Monte Carlo analysis. If I want to visualize it, I have to create a plot. Okay, so I am going to exit the for loop here, and I'm going to call pyplot.hist to create a new histogram from my simulations. The number of bins I can choose, let's choose 100 bins. This is going to plot the distribution of our end prices. Now if I run this code cell, just let it run for a minute because the number of runs is 1,000. Okay, oh, never mind, there you go. That was quite fast. All right, so we get the results of our loop, and we get this histogram which shows us the distribution of values. Let's now fill in some additional information onto our plot. So I am going to go into the same code cell, and I'm going to call pyplot.fig text at 0.6, 0.8 for the size. The S is the label. It's going to be starting price, and I'm going to put in here the starting price as 2 decimal places, and I'm going to fill that with my starting price. Then if I rerun this code cell, I'm just going to have an extra figure text. Okay, we just have here starting price, $368.70. That was the starting price for the Netflix stock. Next, let's show the average final price. So I'll call pyplot.fig text again to add text to the figure. I'm going to do it at 0.6, 0.7, so a little bit lower. The string is going to equal mean final price, and I'm going to show it to 2 decimal places. And I'm going to fill in here my simulations. And from the simulations, I can just use the mean function to get the average. Now I'll rerun this code cell, and we will have a second label. We're going to also show mean final price was 369.84. All right. Next, I am going to show the variance of the price. So I'll use pyplot.fig text, and I'm going to plot it just a little bit lower at 0.6, 0.6. The string is going to be variance, and then I'm going to pass in the confidence interval. So I'm going to say 99% confidence, and I'm going to pass in here to 2 decimal places the variable of my starting price, and then I have to subtract my quantile. So the quantile, I am going to declare that as a variable. All right, so let's declare that quantile. The quantile is going to be a numpy.percentile function. This is going to return for us a percentile, and I have to pass in my simulations as well as a number of values. I just want 1 quantile. So that way I can calculate variance. And also this percentage is going to get in the way, so just remove that and change it to percent because percentage is a reserved symbol. Okay, then we can hit rerun on the code cell. And this time we're going to have our third label. We have variance here at 99% confidence, and the variance was $368.70. Right? And let's see. I'm just going to, next up, let's now display the 1% quantile. So we have this 1 here. So the quantile actually itself is the 1% quantile. So let's display that. We're going to add pyplot.fig text, and we can have it at 0.6, 0.5. And I am going to pass in my string here. The string is going to be my 1% quantile. And then let's put in as a string, we're going to put to 2 decimal places our quantile. Then I'll rerun that code cell and we'll get our results. We're now going to have an extra text. Okay, 1% quantile is $0. All right, now let's plot a line at the 1% quantile result. So I am going to, for that, call pyplot.axvline to create a line. The x is going to be our quantile. So it's just going to be a slope of 0. It's going to be just one line. All right, so x is quantile. Then we're also going to pass in a line width. Let's do 3. Then I'll rerun this code cell. And we're going to get our final price distribution for our Netflix stock after a number of days. And we also get our quantile. Okay, so the quantile was 0. And the value at risk for each Google stock was what we had earlier. And this means that the amount of money we'd lose at most 99% of the time is $0. So this quantile here represents the value at risk 99% of the time, which is 0. So that means that there's high confidence in this Netflix stock. And that is how we can visualize our price distribution for our stock. You can actually do this with any of the stocks that we have. All you have to do is use that stock's adjusted closing price as your starting price and change the sigma to get returns at your stock. That way you'll be able to see the price distribution for all of your stocks. I'm just going to move this a little bit over to the left. Let's change this to 0.3. That way it's not going to interfere with our histogram. Because if you set it, the X value in fig text to 0.3 or maybe even 0.2, that's going to make it easier to read. You can also increase the number of runs that you're doing. Currently, we're using 1,000 runs for our Monte Carlo analysis here. And this means that we're going to be having 100 different simulations, or 1,000, sorry, we have 1,000. But you can increase that to 10,000 or higher to get a bigger simulation. Congratulations everyone on completing another course. I'm excited to see what you do from here, so feel free to share your success with us and your projects. And I will see you in another course.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle. And it's on sale today. So buy before the sale ends. Thanks for watching and I'll see you in another video.